This is just an example. It's just an example. So it's just a quick example here. All right, so the example says graph y is greater than negative 2x plus 8. Okay? This is the question right here. This is the example. This is the question. And below is kind of the steps in which you would show this, okay? So the first thing we need to do is we need to find out, we understand that there are a bunch of solutions for x and y that would make this inequality statement true. So there's a region of the graph that will contain a whole bunch of solutions. So the first thing we need to know is what is the boundary line, or what is the, like what's the boundary that the solutions will kind of go up to and not cross. So in order to do that, what we want to do is we want to change this into an equal sign, and we want to plot this line. So this is now a line, right? So that's going to be the boundary. So we're going to temporarily plot the equation. So you should know that this is y equals mx plus b, right? That's the format for that, so you might recognize that, which is easy to graph because this is the slope and this is the y-intercept. So first of all, 0, when x is 0, y is 8. So 0, 8 goes on the graph right there. We're going to plot that one. Now, you could use the slope or just simply another point to make another. We need 2 points to draw a line. So the slope, actually, what you could do, right, is you could go, the slope means rise over run. So I could go down 2 units and then to the right 1 unit, and that's another point. So what is, when x is 1, what is the y value? Well, that's negative 2 plus 8 is 6. So I go down 2 from 8 and over 1, that's the point 1, 6. All right? Now, if you let y equals 0 and solve for x, that's the other intercept. That would be fine. That would be over here. But all you need is 2 points. Use a ruler, please, or a straight edge of some sort to connect those 2 points. And the second thing we want to look at now is this boundary line, is it solid or is it a dashed boundary line? So remember the difference? The solid means that all of the points on that line are included in the solutions. So that would mean that there should be an or equal to if we're going to make a solid line. But look at, there's no or equal to here. It's missing. So that means that we are not including this line as part of the solution set. And how you do that is you make a dashed line. Try not to make it dotted. Okay, and this is very poor. I'm just freehanding this. You would use a ruler, but you would make a dashed line. Don't do dots, please, because that might look like it's part of the solution set if the values are integers, let's say, or whole numbers. So do a dashed line to show everyone that, hey, this is not part of the solution. It's just kind of leading up to this one. Okay, are we okay with that? Do you understand that? Okay. No or equal to, dashed line. Or equal to, solid line. All right. Now the second point, now that we've got the boundary line on the graph, the second is the easiest. So the second piece in doing this is to find out where the solution region is. It's going to be on one side of the line or the other. The easiest is to use a test point. Now a test point is simply a point on the graph, and you're going to test the value of the x and y's for any point to see if it matches or makes the inequality true. The easiest one to test, if you can, as long as the line doesn't go through the origin, 0, 0, as long as the line doesn't go through there, then 0, 0 is usually the best choice because it just eliminates each variable term, right? Those just simply become 0, so they're really easy to figure out. So this one, if you test point, it would be 0, y equals 0, is greater than 0 plus 8. So is 0 greater than positive 8? Is that true? Not true. So that means that 0, 0 is not part of the solution set. That means that all of the points near 0, 0, and that means all the points on this side of the line are not part of the solution set. We could test more. You could test as many as you want. But all that you need is just that right there. So I'm going to move this over now. So that's step 2. Okay. And then what I'm going to do is I'm going to shade, okay, this part of this side of the line, the other side, because all of these points should make the inequality true. And I would like to just confirm that. So not really a test point, but it is kind of a test point. So 0, 8 is on the line. 0, 9 should be in that region, 0, 9. So I'm going to say y is 9 and x is 0. So this term is gone, that becomes 0. So is 9 greater than 8? Yes, that is true. So we've confirmed that points on this side of the line are part of the solution set. And this is what you would do. You would state the line. You have the line here as a boundary, and then the shaded region, you're done. That's graphing the inequality, stating that all of these points are possible solutions for the inequality. Yes?
How would you figure out if the line is dotted or solid?
Okay, so once again, how do you know if the line is dotted or solid? You simply look at the inequality sign. This sign does not include an or equal to at the bottom. That's not there. So that means that the points that are exactly on this line do not satisfy the inequality. So for example, we know that 0, 8 is on the line. So watch this. If I put 8 here for y, and then this is 0 for x, what we have is we have a statement, 8 is greater than 8. Well, that is not true. 8 is equal to 8. 8 is not greater than 8. So that means that the points on the line like that are not included in the solution set. So the dashed line means this is a border that you can come up to, but you can't touch it or cross it. If it's a solid line, you can come right up to that border, and all the points that form that border are also part of the solution set. Make sense now?
Yeah.
Good. Any other questions? Okay. Graphing inequalities. That's awesome. Now notice that these have two variables. So when you have an x and a y, it's like this. If you just have one variable, then it still could be a shaded region, but it's going to involve a vertical line or a horizontal line. So when it has two variables, we have an oblique or slanted line. Okay?
Old line and a solid line.